Good evening, everyone, and welcome back to another webinar by SDI. This is the first webinar for this year. So SDI is conducting this webinar in collaboration with our esteemed partner, Civil and Structural Engineering Consultants. So if this is your first time with SDI, which it might be for a couple of you, just to give you a very short introduction. Yeah, so SDI is an educational institution that has a lot in store for you. We specialize in engineering, covering areas such as design, construction, and software training. What sets us apart is our close affiliation with Civil and Structural Engineering Consultants, commonly known as CSEC consultants, which is a name synonymous with excellence in the field, having worked on several iconic projects in Sri Lanka. At SDI, we are committed to the continuous professional development of engineers. So we offer CPD courses and events for those pursuing chartership or looking to enhance their skills. You can see one of our ongoing courses. This is actually one of our upcoming courses for the year, the first course for the year, which will be the ETABS course. We are focused on structure analysis and design, architectural modeling, and even some courses focused on specialist topics. What sets us apart from other similar organizations is our exceptional faculty, as our educators are all practicing engineers with extensive real-world experience, some of whom are even renowned in academia, like our resource person today. We also offer a set of publications, including the Tall Building Guidelines for Sri Lanka and the Construction Specifications for Tall Buildings in Sri Lanka, as shown on the screen, with more to come. These books encapsulate our team's wealth of experience, having diving deep into design and construction specifics. There's a lot of experience that has been included in these books, and therefore these books are currently in high demand. So today we are conducting what is the 8th session in this free webinar series, and of course, like I said, the first one for this year. We aim to continue the series with an interesting topic by our resource person, who should be no stranger to you if you have been with us from the get-go of this webinar series. We have with us again Professor Priyan Mendis, as always gracious enough to conduct webinars to better educate and develop the engineering community in Sri Lanka. For those who don't know Professor Mendis, he is currently a professor at the University of Melbourne, and he is a pillar of our institution. He's a world-renowned He's a world leader in innovative construction methods such as prefabricated structures, tall buildings, durability of concrete structures, advanced materials for construction, including base materials, protective technology of structures, wind, earthquake, fire, blast, etc. So as you can see, he has a wide range of experience and a lot of expertise in different fields, which is why he's one of the best resource people that we have today that is well suited for this topic. He has worked as a consulting engineer before joining the university in the early 1990s, and he is a member of the Australian Standards Committee for concrete structures and loading of structures, including wind and earthquakes. I invite you to engage with our speaker and to ask questions. Please take full advantage of this opportunity. Thank you, Professor Mendis, for joining us today, and now I will hand the session over to you.
Thank you, Ayesha, for that very kind introduction. Also, thank you for the patience of people who are listening. And I had emails and other messages saying, please record it because it's very late for some countries. So I had some emails from different countries, but so they will send them the recording. But those who are in the audience, thank you very much for joining. There's a live audience here as well. Thank you very much all joining, as well as the online audience. So I will I selected this topic all the way to tries the topic circular economy, recycle materials and modular construction. As coming from that topic, I put a overarching topics at giving opportunities. Why it's really exciting time for many, because those who are in the construction industry or not has given again this opportunity. And before I start, thank you to SDI, Ayesha, thank you very much for really doing a great job there advertising to organizing this. And yeah, so from here, we will see today I will just talk about more opportunities and how we can capitalize on that. So these are all, I will say, 10, 15 years back, really, like we have been on sustainability. I have been working on that. I always like the environment. I've been working on this for a little bit of time, but it's really the last 5 to 10 years have been really exciting, especially next 5 years, 10 years, 15 years, even next 10 years, I would think. 2050 is where the net zero. We all want to go to net zero, but that is, I know, you could say 25 years away, but time is flying, so we could reach that very soon. But next 10 years will determine everything. Those who are here in the audience here or the online audience will realize that how to capitalize on this, right? Your knowledge. You are here because you like these areas, you like the environment, you like the sustainability. We are doing something for the future generations. So it's really very important. And there are climate summits now and sustainability everywhere. Next week, I'm in Indonesia giving a talk as well, a similar topic everywhere. Interest, I talked in Japan to Athens and all that last few months. So everywhere the interest is there growing in sustainability, but solutions. We have the AEC industry, I think mostly represented, but others as well. I had someone from an accountant writing to me today. He can't join today. Obviously, it's late. Whether we can send the recording. So I will collect all that. Now, it's a topic which will interest everyone. However, because I'm more in the AEC, the architectural engineering and construction industry, so we are. I will focus a bit more on this on the solutions. Now, solutions are the most important. So so they are the most important. Thank you, Aisha. Most important. We know the big picture, but let's start with the big picture. And I've already mentioned this. You don't need to be told about this. The carbon dioxide and atmosphere, it's all real. We have to do something. We all know that. 15 years back and whatever, when we started some of the initiatives, 50% of the population, or it could be US mainly, 50% of the population didn't believe climate change. Other countries, it was a bit more. And however, now it's almost getting to 100%. Everyone believes climate change. So big change now. So it's because we can realize that. And this one, you have seen this graph, but if you look at the carbon dioxide levels on the y-axis and time on the x-axis, you will see that the carbon dioxide levels have gone up so quickly last so many years. An industrial revolution, we can call it anything, but the carbon dioxide levels are the key, and it keeps going. Now, this graph, again, I have to apologize for some who have listened to my talks in different places. I've used this slide because I like this slide because it's no need to be convinced now. I don't like what's happening at all, but it's really, if you see 1913, the ice caps, these are glaciers in 1913. Same place, same time, this picture has been taken, National Geographic, very well-reputed journal. Is showing that 2012, see, most of it's melted. So this is happening, scientific evidence. People were asking for scientific evidence. We got lots of scientific evidence now. This graph also I've shown before, but it's showing maybe this is a bit better. Maybe can we put the video of that? Click the button. So this is clearly showing 1882. See with you can clearly see 1880 to 2000. Thank you, Mr. Mal. Thank you for coming. You have a very busy schedule, so you are still here. You know all this as well, but actually, in fact, myself and Mr. Shomal started the Green Building Council here, so it's really in 2009. So, which really it's really at that time the interest was there, but It's exponential growth. And this is where the 2022, you could clearly see, you saw if you this is from the NASA, so it's a very reliable place showing the the temperature change around the world, similar time. So big change here. We have to believe this, but we don't need to get scared. But because we are finding solutions. But again, I think it's showing again. And in 1880s, I'll show it again because it's quite important. See what's happening around the 90s and temperature changing, increasing. See where we ended up now. So this is scientific evidence, nothing the average temperature, scientific evidence, not really some fiction. But this is happening now. See, ended up in 2022. Lots of reds, right? Lots of changes. So this is all real. So this book, which I always mention as well in my talks, but you've seen me talk about Mark Linus, had a chance to talk to him on stage. But 6 Degrees book, if you have a chance, it's cheap. If you like, you can order from Amazon. And it shows really what he's saying, is really true. I think this book also helped really make some decisions for even the UNs and all that to take these decisions. Because what he's saying is, in 6 degrees, humanity will be real danger. We may not even exist if we go to 6-degree climate, the temperature rise. So we know we are not going there, but this is really getting closer to here, Sri Lanka, where again the disasters are real. Happening, the droughts are happening. We know drought is there. Then now that lots of rain, right, floods and all that. So it's really the climate change, floods now. So it's happening. And earth slips and all that. If you look at the statistics, there are more and more happening. So climate change could be one of the reasons. But yeah, so that's why in the world, again, I will focus my talk on the opportunities for everyone. Really, we are not really opportunities to really make a difference. So I have to apologize. You have seen some of my slides in different forums around the world, but if you have seen them, but so COP26 started all that, but let's look at the 1.5, that we wanted to have 1.5 centigrades and the 2000 by neutral by 2050 with the 1.5 degrees. So then now they are saying it'll be 2 degrees in 2050. So not just 1.5 degree. Even that we are taking solutions now. Now, I was talking about big picture still, but that's why we are all here. We are the ones who can provide the solutions. We are the problem, right? Built environment is the problem, right? We'll be blamed for creating all this. It's the other way around, actually. We are the people who can provide solutions. Built environment is really at least 40%, responsible for 40% of the carbon dioxide, carbon side. So we are the ones who can provide. AC industry is the one which we can provide all the solutions. So all this work done, 2050 net zeros, everything, still we will only reach. We will be below 2 degrees. If we didn't do anything, we would have reached that 6 degrees. So by end of the century, I think Mark Linus says we would have come close to that. So these are future generations would have been real danger. Now we are doing something. The world is really scared, right? And those days, everyone thought the cost and economy is the only thing. But now the sustainability has become the number one priority. Again, I will mention this later on also when I say opportunities. Banks in different countries are really have banned really like non-green initiatives. They will give only funds to we call it superannuation in Australia, but ETFs and all that. But when they're funding funding the different projects, only the green projects will be given loans funded. And yesterday I had myself and Mr. Shomar met the Mr. Lionel, who's managing the Green Building Council now, but he's now saying that banks are happy to give, every bank here, happy to give a 2% reduction in if this green initiatives, they will reduce the the interest. That's what they're working on. They agreed to that, and it will happen. If you borrow 100 million rupees, right, and that is 2% is a significant amount. So even if you say our house is green, we may be able to claim that that rebate. So that's going to happen in a big way. So all that's why it's a financial now. It's not just the really on paper. I was just before this meeting, I was meeting the president's main economic advisor, and he was just saying that even they are promoting, government side is in charge of the port city, but so they are saying that the sustainability things are really going to be really encouraged. Otherwise, they will not even consider some of the investment coming into. He's a chairman of BOI as well. So Bureau of Investment will only consider projects green. So anyway, this influence, the policymakers have now come together and influence the really the sustainability side, encouraging. Before it was only the dollar or the rupee numbers, but now that again that will have other implications. Getting back to this, you already know this one, but you want to remind what is circular economy. There are at that time, now if you have straight line, the linear resource extraction, we extracted the resources, we produce, we consume them, and we dispose the waste as waste. Put it to landfill or anywhere, throw it to the sea, throw it to the rivers, right? So we did all that. But now, with the circular economy principles have overtaken, circularity is the word that we'll hear forever. So everything will be circularity, right? Every project we have to show that circular. Singapore has already started. You had to show a circular solution, even dismantling a building. Afterwards, end of life, we call it. End of life, what we do, we need to start thinking like that. Produce, consume, and manage the waste, and then convert into our materials. We are running out of construction materials. It's very high. Even here, I know it's gone up. Australia is 30-40% extra now, the construction materials from 2 years back. Right now, that's why you need the solutions. And there are some policies have been implemented in Australia. That is, all the road infrastructure projects have to have recycled materials. Really, they can't use any material without a recycled content completely, otherwise they won't get the job. Other thing which has happened, people, I think it'll come to the other parts of the world as well, people going for tenders in projects, buildings, and also the construction companies going, if they can provide a green component to say there's a base case, some base case, once you define the base case, if they can go 25%, right? It's not just what you put into the tender, the cost of the work, but how much you are going down from the base case, that will have an influence on the decisions. So that's really, these sort of changes have really been implemented I would say last 2 years. I can see every year is changing. When I talked last year here, I don't think that was there. That's sort of some of the things, but now it's changing very quickly. So again, as we have a lot of younger people also here, both here and the online audience, but there are many opportunities will come to really use it. Anyway, let's say here, I had to say my other story as well, but those days we used to say, don't go around circles, right? Try to go straight, but now we are saying go around circles, right? Yes, we are saying. So that's the saying, you can read. But the principle of circular economy, again, these are a little bit big picture, but eliminate the waste generation and pollution, we call it decarbonization. These are 3 key things that we have to follow, the 3 key principles. Circulate the materials in use at the highest value, design for reuse. When you're designing a material, always think about the end of life, the designing for the reuse, and regenerate the natural systems. We are running out of natural systems, natural resources. So we need to really eliminate the use of natural resources. I will talk about a few examples, but think of river sand or something. We just take the river sand out and we use the natural resources. And there's a certain limit we can do. We are running out of river sand everywhere in the world. So we are running out of other things as well, not just the aggregates to many things in the construction industry, all sort of materials. Why not replace them? Start replacing them with the other materials. So try to also regenerate the natural systems. So again, this is the opportunity. Everything will be linked to the sustainable development goals. So if you, actually I even put that up, the award of 2023, I think is, yeah, anyway, the sustainability award I got here. Now, but on there are a few others actually. Athens, I got award as well this year, so I have not updated the photo. So the construction, if you have if you put the plot them, the construction industry, how many, this linked to many things, right? The people, 1, 2, 3, 4, right? We'll be not talking about anything else in the future. This is going to happen, right? When I talk next time, it will be even more. People are thinking how anything in your life, not just construction, no, everything in the life will be related to the UN SDGs. When UN SDGs were advertised, no one cared, say they are just numbers. Even in Melbourne Uni, or not me, there's one of my friends organized UN type of conference. I went there, but I was not that interested in listening to one of the key UN people coming and talking about UN SDGs. I know I was very interested in the environment, but I wasn't sure how all that can be linked. But now it's very clear. Take the construction industry, because we are dealing with people. We are dealing with the society. We are always making something for the contribution to the society. So these are the opportunities. So every UN SDG will give you, I will not go through all that, you can easily read from the web, these ones. But this diagram, I didn't do that, I got the reference here, but Dr. Graham has done is try to put the construction industry to really put it to how it's linked to the UN SDGs, people, environment, and means, society, the more of the economies and all that. So UN SDGs are covering all that, but also touching on all that. And 11 is sustainable cities and communities. You will hear a lot more. 7 is affordable and clean energy, and very much on the other one. So just thinking about how it will give you opportunities and to really linking that. So start thinking about a bit more of that. So impact of buildings is really, I mentioned this, consume about more than 30% of the world resources, up to 40% of energy consumption, 40% of waste materials going to landfill, but it's going to, it's increasing. So we are the main contributor, the built environment. I talk about the main contributor to that, as I said, to the problem, but then we give solutions. Now, again, I want to, when I was giving a talk to audience in Australia, the engineers, I asked how many people know about why it's happening, why concrete is a polluter. We go and say, yes, true, concrete is a polluter. So this is simple, but I want to just remind you, because when I asked how many people knew, there were only very few could say that they know why concrete is the worst polluter in the world. But that's why the solutions as well. So what's happening? Very briefly, if you're not sure. So in the cement production process, we convert the limestones, calcium carbonates to lime at around 1500. So huge amount of carbon dioxide is emitted. So you see, it is not the other processes which really provide that the pollution, carbon pollution. It is this process, limestone to heating to get the lime to take that takes the carbon dioxide out. Now, why we are studying up to this level? Now, I've done concrete for a long time. Even I didn't bother looking at this 5 years back. But now, to provide the solutions, so we can attack that. We know this is the problem. So why don't we attack that? And today I will not have time to talk about all the processes. So what we are doing, I can say in words, that is the in this process, we capture the carbon dioxide. We means the cement companies capture the carbon dioxide. So different type of carbon dioxide they can capture now. Once they capture, it's very easy. They have changed the processes. Hansen has already starting to do that. Others will follow that. They're changing their process, this process. So to capture the carbon dioxide. So different levels of purity. So that's also important. But I'm going to say, so what we are doing, I have a PhD student working on, I'm sure I'm not the only person working on it, but PhD student working on that capture carbon dioxide. We are running it through the recycled concrete aggregates. And that then recycled concrete aggregates, I'll show you, I'll say why it's important. Today I didn't have time to talk about a lot of slides on that, but I'll say this. That's the solutions. Now, recycled concrete aggregates are the demolished concrete. We don't use it. The world, we just throw it to the landfills before. Even anywhere in the world, we just thought that it's too expensive to take the concrete, just demolish, throw it somewhere is the quickest. And now what we're doing is all the recycled concrete aggregates. I'm working with Mr. Jamal also on this. I think Hafsha is here as well, but I think they're working on this. But the recycled concrete aggregates, and Dilan, I think as well, anyway. But I want to get some quick solutions. Next time when I talk, we'll have solutions here as well. But the recycled concrete aggregates has two different surfaces. One is the old cement paste or concrete paste, cement paste, and the new one. Once you put to the concrete, once you make concrete, you'll have two surfaces. Other aggregates have only one surface. So again, going back into the deeper, concrete fails, as we know, compression strength usually is because of the ITZ zone, the inter-transition zone between the aggregate and the cement paste. So that's where the tension, due to tension, concrete failure is always a tension. It's a compression, we are testing cylinders, but when you think of it's all tension failure. So anyway, I'll talk about that another time. But the bond between that aggregates, the weakness starts from the aggregate, the cement paste. That's where the weakness starts. And that leads into micro cracks to then finally it's a compression strength failure if we test a cube or a cylinder. So these two surfaces, what we are doing with carbon dioxide is that is strengthening. So the CSH component, which if you want to go deeper, CSH in the concrete reacts with carbon dioxide and you get more calcium carbonate. Calcium carbonate is strong. So because of that, the recycled concrete aggregates become strong. And those days we have a saying in different countries, 30%. 30% is a magic number. We can't even find where we came from that. But 30%, only maximum 30% was allowed of recycled concrete aggregates in the concrete. Now, what's happening with this carbon dioxide process? We think it will be 100%. Recycled concrete aggregates can be coarse aggregates can be replaced 100%. By these processes, close to 100, let's say 80%, 30% to 50%, 60%. So we start with 30 to 50%. Other thing we are doing there is innovation is that we think the graphenes, carbon-based graphenes, which we've done doing work, will improve that carbon absorption process. So that PhD student is looking at, she's originally from KDU, looking at that carbon dioxide, how it will improve the recycled concrete aggregates surface and even a bit further. So we're going deeper into that, trying to find solutions. That's an example. So there's a problem. This is the main problem in concrete. We have to try and find some solutions. So we all here or the online, just will find some solutions as well to this. And that's one example. I will not spend too much time. Every company, this is a document, 2021, but it's a corporate net zero standard. Companies are the carbon footprint reduced by 90%. And again, it's happening in Europe. And I think we all will follow that. The companies, greening the companies, the structures, everything, the greening the everything. This is going to happen. There are some documents. So what are we doing here? We have to really, how do we do this? The net zero commitment especially coming from the Green Building Council, but this one, but there are others also similar. But so we want to reduce all operational carbon emissions by 2030. 2030 is only 5 years away, right? Already 2024. You see, half of January is gone. So we reach 2030 very quickly. Right? We don't have time. I don't think we'll achieve this one, but also all the buildings, and they want to say all the buildings reduce embodied carbon emissions by 2030. It's not going to happen, but at least there are some goals we are following. So if we get to in 2035, 40, 45, it doesn't matter, but we have some goals. So that's why we need to do the operational carbon. Those who are new to the area, some could be listening. The operational carbon is where the energy we are using, the energies here, putting the lights here, the operation of these buildings. And I know this is very much a green building here where we are in the CSEC building, but there are other buildings are not being designed like that. Some of the older buildings, especially. And so operational carbon is that. Embodied carbon is for the materials as well. We are all here in this room here. When this was built, and is something unique here that is under this here, where some people who are like, where you're here having physically, underneath this is there's a waste materials of every type of waste material. I won't have time to talk too much on that, but waste materials include apologies, those who listen to me on this, but before saying this, but the waste materials we have used rubber, the textiles, plastics, we have used paper. Mr. Mal knows about this. Could add to all sort of things. Both of us directed this have been used. Finally, I think Mr. Mal suggested get some human hair as well. So why not? So we put everything there to show that, and the textile is obvious, right? To show that everything can be used, just not one material. So what we did in this structure is that it's a unique one. Is that underneath here you have that waste material, but to bump up the compressive strength, obviously, we are introducing weaknesses, right? The best materials are the aggregates and cement and all that, but we are introducing some waste materials. Our compressive strength is going to go down anyway. So we have done some measurements here. We are writing some articles now on that. But then we use graphene oxide to really bump up the compressive strength. Graphene oxide is also, graphite has not been used efficiently before. So sort of a waste material, it's a natural resource, but it's a sort of wasted material. And so we use that as well to really give a solution. So these are the kind of solutions you must think. You'll make a lot of money in the future if you work on this. May not be tomorrow, right? But don't get discouraged. So just keep working on them. And we know all these things already. We know where to put energy efficient lighting, solar panels. We know all these simpler things. We know green roofs had to be done, but there are still these concepts have not been absorbed too much. The green roofs, the water efficiency. I know around this building it's been done. The water efficiencies, acoustic and thermal comfort, the air quality, indoor air quality, indoor air quality IAQ is a key thing as well. We had to measure that, and I know even in this building we have tried to put some sensors, carbon dioxide sensors, and other thermal to measurements. Performance has to be measured. That, as I said, the big picture time is over now. We say, yes, we must go and do these things. That time is over. Now we have to say, monitor it, provide the solutions, do everything, try to reduce, improve all that, but then embodied energy, operational energy improve, take some measurements, monitoring. Those days buildings were designed, we just only design stage included. But I know this building has been monitored, audited, the energy under Shuma's directions, but what is solar panels are providing a fair percentage for a 4-5 story building. It's 50%, I think. 50% is a lot. So that means if it's a single story building, it'll be 100%, right? because going taller and taller because roof area is the same. So 50% efficiency is a lot for this type of building. So this building is achieving those targets, but that's been monitored. So monitoring and doing that is quite important. What we have been doing is to try and say, right, yeah, we are doing it, but we don't know the performance. So in the future, the monitoring the performance will be a key. Anyway, daylighting, and the daylighting, the again is quite important. As you know, here right now it's been done. Low emitting materials, the VOC levels of the compounds, and to also low emitting materials. The human comfort is a key, and there was a talk from Professor Louis last month here in Colombo on the healthy buildings, because healthy buildings is a key topic as well. So and so this will come. Alternative transportation, right? Sometimes we can do that, try and walk as much as possible, but again the bicycles sometimes not easy, right? To use bicycles. Sometimes the world is going too far on this. In Melbourne they converted all the it was very easy. Some lanes they have just converted into bicycle lanes, right? And completely stop cars going, or very messy. We shouldn't go overboard, but I think we had to really allow alternative transportation. And I was in the Green University yesterday, meeting the Vice Chancellor. What they have done is they have Vice Chancellor banned cars within the university. You had to use other alternate vehicles, buggies and all that to really go so no cars inside allowed. Like that, the people are doing things too. So it's important. Recycling, we talked about recycling materials already absorbed. So there are some things we can do. We talked about a big change will happen. As I said, the buildings have only a limited amount of roof space for the solar panels, but the facade integrated panels, transparent PVs are becoming important. We also have a center in the university, not my group, but there's more electricals and electronics and all that. They have a center of excellence on looking at some of those facade integrated transparent PV. We also had a project, but again, that's something you will see more and more for the windows and all that, the solar panels. Also, people are looking at, of course, before only the solar panels were only now on the roof, static, but now, of course, we rotate the solar panels, as we know, in solar farms especially. Solar panels get rotated and follow the sun. So to improve the efficiency, it's happening in solar farms already. So these sort of newer things are happening. Also, the efficiency of the inclined panels being looked at a bit more. Try to extract a lot more energy, solar energy and conversions, trying to get that through. So this one I will not go through that. If you want to look at a building, which is a very good building of where the net zero operational carbon. So these are the solutions. I will not, if anyone wants the slides, we are happy to really distribute. But these are solutions which really, some of the solutions, but don't try to read this. I won't have time to explain all that. But look at only that example, put it in the web. Web has got a lot of resources. Arthur & Century, Pacific Tower, Manila. If you look at that, what they have done, Mr. Rasikese may tell us more, but HVAC systems with an average energy efficiency rating ER of 15. I don't think it's easy to achieve 15. So, right, we are not achieving 15 to that level. But these are the things that we are improving all the time of these energy efficiency ratings to all the systems, HVAC systems, to many other systems now. So solutions, don't read too much here. So what are we doing here? We are always think about engineering in a net zero system. If you are engineers, architects may come and say, yes, architecture in net zero systems, right? Construction in net zero systems, even manufacturing in net zero systems. And if you looking at how that can fit into the net zero, working towards net zero, that's the opportunity. I started to talk about the word opportunity today. That's my keyword today. How these things will bring opportunities once you provide the solutions. And it'll be dollars or rupees. See this here. One of the companies the been floated, and it's going to improve further. And I think the about 18%, I need to update it, but it could be more now, but 18% in 6 months. So this is just floating on the carbon credits. I will not have time to explain what carbon credits are in detail, but carbon credits are where the carbon offsets. Now, big polluters, like I also work with some oil and gas companies, there's no way for them to make it to zero, right? They can't really carbon dioxide emissions to be zero. So what they'll be doing is they'll be buying carbon offsets from agriculture industry or any other ways. They will buy the carbon offsets. So offset their pollution. They will try to reduce it further and further, but then they buy the carbon. So these sort of companies are there, carbon numbers. So they trade in the carbon. So that is, you will see a bit more. I'm talking about a bit more next few years as well, which will give you opportunities, right? If you are, I think you can start looking at some of these companies, right? I should don't record this what I say if you lose money, but you may, if you invest today, I can say right now you should consider some of these companies now coming up, carbon trading companies. That's starting to come. So what London has done is jump one step ahead, and then say it's the first. They talk about the net zero financial hub. Actually, Europe has been there. They had a very big head start. They had lots of grants, all that. But when I visited in June, I thought Europe is, London. I was in UK. I was in Greece to a couple. But I thought they have mastered everything. But it's not true. It's really they are they are still working on it. And so London is talking about a net zero financial hub now. So because they released the green economy and all that, because linking those carbon credits to carbon dioxide emissions to all that to really as a business venture, so financial trading. So one day we'll be allowed to trade the carbon numbers, carbon to rather than the rupees and dollars and all that. So carbon will become a commodity, will have a value. That's what they're trying here. So start reading some of that, and you could be investing in very good ventures, even financially. So this, I had to show this slide. Sorry if I apologize, you have seen this. So this is a good example which I'm promoting. I have promoted Australia, but I'm not the only one there. But even here, Mr. Umar also helping me. But we're promoting this as a product here. That is the industrial hemp, right? It's industrial hemp, which is the timber is going to be very big. Those who listen to me in December, I was talking about mass timber, how timber is going to be a key construction material in the future, right? But natural timber, they are banning natural forests because we can't really use timber from natural forests. So what hemp has 2-3 cycles per year. So hardwood, if you take teak here or any other hardwood, takes 15, 20, 30 years to really grow and for us to extract the timber. But this one, so carbon absorption. So what we do is having this growing hemp, it goes up to about here. And I think there's some, I was with the minister a few days, last week, they're talking about bringing something to the parliament. The state minister, I think, trying to bring to the parliament, no bit more acceptance of this hemp here in Sri Lanka. But Australia already have allowed some of the hemp to be really legalized. Legalize the agriculture side of it. But same time, don't follow this one, but US has completely, number of states completely legalized even the marijuana form, right? But I don't think we should use that to promote that. But they have said you can buy over the counter, right? So these countries are really, but not this type. I'm talking about only industrial hemp. There's no value like that. TCH content, as they have written here, is THC that's the one which really, if it's medical cannabis to marijuana and all that, THC levels are very, very high. You try to make it very high. This is no value that way. Less than 0.3 is the industrial hemp. That's what we are working on. So in Australia, we can have only 2 crops per year. Here, if you do 3 crops, because tropical countries are the best weather, but we need different seeds. So what we do there, I'll tell you the carbon story, solution story, is get the hemp, get the stem of that, and we dry it through a decodification called decodification. Dry that, use fibers. Some of the fibers can be used for textiles, right? Some countries are already doing that, but it'll be improved. Hemp clothes, and some of the, they're already going to some of the hemp clothes, the fibers, these type of fibers. And the herd or the chips are like put into panels. We try to put it into panels. Panel like at the moment is more non-structural, but it can be structural as well. We are working on structural. And those ones will be bound. The binders will be in the future. We have epoxies. Those who are used to epoxies, binders and all that. We can get a glue and just bind them, but we are now working on bio binders. That's be the future. Next few years will be bio binders, bio-based binders. Chemical binders will go away, right? Unfortunately, even our building industry will move to, it may not happen next 1 or 2 years, but we go into bio binders. So you can make a lot of money if you start working on starting a factory now on bio type of binders. You can export it. Countries are already, have a bit more premium on those binders. Anyway, so what we're doing is with herd bio binders, we convert into that. This one is a hempcrete. That is lime, water, and the hemp together. Hempcrete is like more for partition walls and all that, but it can have even like a higher compressive strength. Hempcrete is the one. So here the plant is converted. Plant absorbs carbon dioxide. Also the soil, we call it soil sequestration. Soil absorbs carbon dioxide as well from the plant. So growing this tree both ways, absorbing atmosphere carbon dioxide as well as having from the soil. So that way the carbon dioxide is eliminated. So, and rather than staying for 15, 20 years for the trees, here, 3 times a year cycles will be 3 times. So there'll be some quantification of the numbers. That's the government grant. We got a big grant from the government to work on that project. So you'll see some answers in the future. Anyway, smart cities, I will not talk about that. How the UN SDGs are directly linked to the, you can read that one. I have just given this link here. It's a UNESCO document. If you look at that, smart cities with net zero, you see it can be linked, the smart city concept can be linked in different ways, net zero. Every one of these will have an industry, right? People are already starting on like the green security, right? Economic developments, green energies there, green communities, green healthcare, right? Healthcare is becoming green. So this is already happening, but you will see a bit more. So the emerging, the green cities, the smart city concepts are really Green Building Council. We are working through that. We are working on some of the cities here, sustainable cities. I was talking today to the chairman of the Port City Commission, Economic Commission, on the Port City. He said already Port cities, they are green. They are doing green things, but I said a lot more to go. So because anyway, that's the message they're getting from people, but which is not true. He's economist, but so he said yes, we will definitely look into that. But he said it's more with the Chinese owners, China harbor, which really had to be controlling that bit more to make sure that it becomes sustainable. So anyway, coming back to that is with the solar farms, this is happening all the time, the solar farms, and I will not go into that. Super batteries are coming now. We need to really, the solar is a problem, and the solar, we need to really store in batteries, because otherwise we know only during the day we get solar power. So we need to really get into the super batteries, all that, and we will have the batteries. Then again, a PhD student, which I know linked, I follow this work, the grid stability. We have all these solar farms, solar coming from the houses and all that, then the grid is very unstable. So that's why we need to make the grids, stabilize the grids. We can have all that, but all that will happen. Will give more opportunities as well. Coming back to that opportunities onshore versus offshore, we have done some onshore wind farms. To get all this energy, we need all the energy, the wind turbines, onshore wind turbines, offshore wind turbines had to be done. And even in this country, we know offshore wind turbines had to be popular. We have a shallow foundations, which in one of the projects I was asked to really think about a foundation 15, 20 years back. But then like no, I was just telling them we can put the foundation on the rock because it's so shallow. But again, then there are some other side people saying offshore wind turbines, the biodiversity will be a problem, the fish and all that. Birds will go into different directions, but that birds will find their own way, right? Birds also will understand net zero one day. It's not that. So they'll try to help. But no, it's naturally they will do these things once we have a offshore wind turbine. So everything, there's some resistance, but I think we had to have some offshore wind turbines as well. Anyway, coming to the energy side, we know the green hydrogen, where the water is broken. Water, again, for the process, we need wind turbines and solar panels to provide the energy for processing. Break the water, simple as that. Hydrogen comes, breaking the water into hydrogen, and then we transport it. That's in Los Angeles. So, but other countries also will have the pumping hydrogen. And trucks in Europe are hydrogen trucks. Many hydrogen trucks are there. So green hydrogen will be there. Biodiesel as an alternate energy fuel. This is something we can. I will not explain too much here, but it's sort of obvious. This diagram, again how the biofuels, the biodiesel cycle. Again, the biofuels are a future as well. If you want to have alternate fuels. So start reading about it. You can even start some industries related to that. That will really go very well. Again, let's start reading about biofuels. You will get all this information. I had to prefabricated modular is a topic you have. Some of you have heard I'm talking about, but just for the I want to say the prefabrication is going to be a solution, big solution for circular economy because of the reduced construction time. Let's come to that. I'll be very brief today, but so what is prefabrication? Those are new modular structures are you do it in the factory, brought to the site, lifted up, simple. And this is going to be the future, a big thing in the future. We are doing prefabrication, but this is a 3D. Like modular means it's a full 3D. If you prefabricate panels are also very important, but they are 2D type of elements. But 3D, the whole modules are being cast. So 3D modules will become even more popular. So prefabricated panels, yes, those. If you do it on site, so see the advantages. So of the fast construction on the right hand side, you will see the tradition, one of the buildings being constructed delivered with finishes and facades, incorporate stairs. Everything can be done. Reusability, that's the key. So end of life, when you think of, we have to give solutions in the future, the end of life. What do we do? Those who are seeing the Qatar Stadium, one of the stadiums, they just remove them and put it somewhere else, the whole stadium structure. Because the main problem with the Olympics and all that is that during Olympics, you need so much infrastructure, so many buildings, all that. After that, we not used it. So better to have them reused somewhere. So that's the solution that we provided. Brisbane Olympics 2032, Paris is coming up soon. I don't think Paris have found all the solutions, but 2032 Brisbane Olympics, they already, in Australia, they already started thinking about the modular as a key solution. And because they want to, after finishing, they want to relocate it somewhere. Right? Then our own house, we may think, in the future, we want to move somewhere. Why not we move the house as well? So it's all, so we'll be thinking about modular houses. So it's easy for us to move and go to a different place, relocate it. So these are the things that will happen in the future. But again, apologies for those who have seen this, but this is a kind of full module. My start to the modular long time back was through this project in Melbourne, was done in 6 days. But so I had a chance to work with the one who really, I would give a lot of credit to the architect, Fender Castellis, who was an architect for the Eureka Tower as well, Fender Castellis, but the big building. But he came up with, he wanted to, he spent lots of his time and money to really come up with these prefabricated concepts. I would say 12 years back. That's my start. I used to know him. But then there's another tallest, one of the tallest modular buildings in the world is in Melbourne. Again, Dr. Shan Kumar, who's originally from Sri Lanka, one of my very good friends. I was also there. He's the one who was the main brain behind that the tall Lathrop Tower structure in Melbourne, 42 stories, I think. But so world is moving quickly, but not enough. We need to move very quickly. Then see here why the modular construction. Today I'll be very brief on the modular, but the circular economy, prepared modular construction for circular economy, waste generation, right? And we are doing it in factory, so waste is very minimum. If we do it on site, definitely there's a waste. We can't reduce all the waste on site unless we do all the prefabricated. So prefabricated reduce a lot. So this will become, as I said, the way of construction. At the moment, I know Mr. Shumar thinks about all the time these things, bring some innovations to the construction. One of the very good projects, the North Sales, which is really prefabricated structure, been completed successfully from here, CSEC. But the modular designs enable not only off-site construction, but off-site demolition as well. So end of life, what do we do with how to demolish? So we'll be thinking about flexible connections, how to remove them as well. Those days we went and welded the steel structures, right? No way we could remove them, all that. But now we go and try to bolt them, possible, so that it can be removed. So similar solutions can be implemented. Even if you're doing joints, you can do concrete joints, but put some steel connections to so that it can be removed. Or even concrete, we can come up with some innovations in the future. So these words, disassembly, reconfiguration, reuse, it's obvious into the construction sector. Other thing is that we have to think that the buildings are like, buildings are banks, right? We can go and withdraw money, right? We know banks, right? We can go and withdraw money. We know only how to withdraw. We don't know how to deposit. No, it's not. It's a joke, my joke. But no, we know both, right? But the material banks, we have to think like the buildings are like material banks, right? We have to think like every material we use can be reused. Construction is a huge amount of. I may not have time to discuss in detail, but they think like that so that we can really reuse them, and even when it's demolished. And so I will not talk too much. There's a YouTube talk under prefabricated modular construction, a talk I gave for the AIT Bangkok. The COVID came, so I was just doing online, but I was supposed to go and deliver that Meet the Expert series. They got the world's number of people in different experts in different areas to regularly come and talk about different topics. So you will see that in the YouTube. I want to just mention one word here. I know we are running out of time, but the quantification is the future. Start thinking about the quantification. One example is one of the buildings that I was involved in as a young engineer at that time, but in Melbourne. But so this building I selected because I had all the drawings still. I kept the drawings and the case study. That's a building. It's about 45 stories. Now, this is the building with one of the first buildings we used the post-tension beams in early 90s for the long span beams with again with the core joining, eliminated all the columns, had the post-tension beams. The Anyway, in this case, I will not go into detail of I'll give some answers here. Embodied energy, material. You calculate for what are the materials, calculate the embodied energy. There are embodied energy databases now. ICE is a word that you can search for in the web. ICE is not the Institute of Civil Engineers, but it's another organization, something to do with carbon economy. So I forgot the exact name, but ICE database. That's what databases give you some crude numbers of the embodied energy for different materials. What we are doing, some of our students are doing, is to improve those numbers. At the moment, there are some wrong answers floating around, right? So we will get some wrong answers. In other countries, it's already happening. Some of the projects have been wrongly assessed because the accountants have become the ones doing the carbon calculations. They don't understand the materials, right? There are good accountants who could learn, but they had to. But the industry people, construction industry people, are the best to really assess the carbon. Embodied energy is the energy in the materials used for the building. Operation energy is where you just do the calculation. This one we use a program called TRANSIS, highest level analysis program, and Professor Lue is the one who came here, introduced to us the TRANSIS. He's part of this work. But when we do the quantification, operation energy, we calculate accurately. There are programs like eQuest and few others, simpler programs to do the calculation. Calculate the embodied energy, operation energy, then total energy over the 50 years. Whole life cycle we need to consider now. LCA, life cycle analysis, had to be considered. Now we had to even include the end of life as well. Another thing one of our PhD students doing is that the DCLA, that is the dynamic life cycle analysis, DCLA, that is what we are doing is one of the first in the world, I think, DCLA, but we are doing for a timber structure, that PhD student from our group, my wider group, but doing that, we are monitoring and you readjust the life cycle because we do the calculation based on our designs and all that. We don't know the actual performance. So measure the actual performance, bring back some data back and doing a loop type of analysis. That is the dynamic LCA. So you can start reading some material. Even our student is starting to write a paper. Anyway, these comparisons had to be done. If you had to have two solutions for a project, you need to do these numbers in the future, right? It's going to happen. And see here, in this one, we have just calculated concrete versus steel. There are some other papers also under our names. But here, see the numbers, embodied, don't worry about the exact number. So here, embodied energy is, steel is a lot higher, obviously. The concrete is, in this case, because steel is actually, again, if you're using green steel, is different, but now, so these are solutions. You need to do the solutions. In this case, operational side, heating, luckily for here, see the saving. If you're in a tropical country, that 95,000 goes away, right? That component, but cooling will be a bit more. So these sort of things are there. So the total is there. Then total of 50 years we calculate the embodied, and then do for the solutions. And then once you do the total solutions, the total GHG emissions, not too bad. The concrete solution is only 1.9, the magic number over 50 years. You need to give those numbers. I will not go through. You see, now you can read from the web, total carbon dioxide per meter squared of the building, pro area, once you calculate. So the one having the lower number is the solution that the client will really use. Clients didn't care about it too much before because they were just only, if you give this one, they say, what are the dollars, right? They didn't worry. But now the banks are giving 2% reduction for these numbers, then they will start thinking about these numbers, right? And that's why I think, as I say, a very nice trend happening. When I was talking last year, this time, banks were not doing it. Now, in 1 year, I can see number of banks around the world, not just one country. Here is happening, considering through the Green Building Council, working with the banks, considering those reductions. But other countries also, it's happening. So now people take notice of it, right? So You will see a lot more. In 2 minutes, I think it's okay, another 5 minutes. Sustainable applications of recycled materials. So we have the, again, I will not go through this. These are obvious as well. The waste materials has to be, maybe I'll skip that one. We already talked about the construction waste. We can extract the concrete. I talked about recycle concrete aggregates, extract the concrete metals. We can reuse asphalt paving. Asphalt's being reused now for roads. All the asphalts have a recycled component. Timber, recycled timber. We also have a student, working PhD student. I think she was best top of Morato Uni last year. She's working on the timber, the recycled materials, with trying to get the timber and then use them as recycled materials. The gypsum, wallboard, roofing, bricks, all that been used. So I will not go through the barriers and drivers. There are many drivers now. I talked about policy at the beginning. Policy changes are happening. And the end of life cycle, I talked about that. Carbon credits, as I said, the carbon credits are the carbon becoming like money, the commodities to money. There are barriers still. We don't know enough of that. Procurements, processing costs, the mechanical properties, we don't know enough. We don't know about the durability of the mill. So what is happening in 20 years? So we need to have some accelerated test. World is not ready with everything, but we have to start using that. We need more field applications, right? This is a good application. Mr. Shomal, I don't think you have seen any cracks here yet. So these are the good evidence of the field application. We can proudly say, yes, we have used these materials. There's no problem, right? Tiles have not moved here. So that means it's fine, right? These sort of proof had to be right now is provided that gives the confidence to the people. That's necessary. Standards and specifications. I'm leading a committee in the Australian Code Committee subcommittee. I'm part of the main committee for a long time, but I've been asked to lead a committee on to look at the waste materials when it's used in concrete. What are the implications for the standards, the codes? The specifications will change, and we need to bring that. So research and innovation are the collaborations are the key. That's why we are doing all that work on the research. Some examples we can easily do in the lab now. Again, as I said, a lot of things, we can do lab. Right? Lab, we can replace glass. You see papers when you read lab glass replacing the sand or the aggregates in concrete. Just in the lab level, people have done it. We are one of the first to do it, but other people are doing it right everywhere. But we take the glass and crush it. But we are the first one to probably use the world to really in a real big infrastructure project. We have Metro Tunnel project in Melbourne. Just started with some temporary structures. They mix the glass. We have a process called vortex process, like an aircraft engine, where it breaks the glass and breaks into smaller particles. Those who are interested in numbers, I can give you. We can go up to 40 microns type of glass level, crush it. Once it's crushed, they can be just used in concrete. And again, those who are interested in R&D, we want to break those particles in further. If you go down further, glass will even have some positive properties like cementitious properties. So I'll leave that for another day. But SiO2 levels and all that will help us to convert it into cementitious levels. So we think like that. There's no one has done this work. We are very slow. The world is moving. And so we have a lot of glass now. Start thinking, putting into concrete. That's and the difficult part, as I said, the Holcim, their main problem was the glass was hitting the pumps as well. So we are not ready yet for these things. They were reluctant to do it because so we work with them improving the pumpability, the fluidity of the concrete and all that. So to really improve the that problem and eliminated the damage to pumps. So there could be other problems working with the field, the industry, using that. So that's that project. Then we are using some plastics in concrete to other things, sorting with AI, use AI to sort the plastics, different type of plastics, convert into some building products. This very briefly is that the slabs, if you use void formers, you can reduce the slabs. So all the concrete slabs in now Melbourne, especially in Victoria, they use these void formers so that concrete content can be reduced. And slabs on ground, but void formers. Void formers used to be polystyrene. Polystyrene will be banned in the world, right? But construction, we still need them. It won't be transition stage, but because polystyrene is a big polluter, it doesn't degrade. So it'll be banned. It's a very much the polystyrene will even the environment pollute as well. Small pieces go everywhere. So polystyrene will be banned in the world. Some states are already considering. So what we are doing is polystyrene used to be polystyrene. We are converting to recycle plastics. Very quickly, AI is used for the
I'm sorry, I didn't quite catch that. Could you please say?
This is the AI. No, because it heard the AI word. See, it's very smart. It just heard the AI word. That's I had to. Sorry. So, sorry. That's okay. One recently, when I was giving a lecture, said, "Your time is up. Just stop the lecture now." So yeah, this is very good AI, right? We had AI for a long time. We don't realize. So we carry AI all the time. So anyway, AI for waste identification, and with the this Dr. Kasun Chanaka's project, actually he's looking at robots being used to creating a database and using different type of plastics, and he's getting some robots to do this as well. Vision, I'll leave it that for another day. But graphene is again as a single. I don't have time to explain, but those who are new to that, but some of you have listened to me. But a single layer material. If you take a pencil and draw until very thin, you get graphene. We can make graphene now if we have pencil, right? But systematically do it. I was in the graphene factory yesterday, CGT factory in Homagama, but they are trying to do it systematically. So the graphene oxide, when it's converted, it's water soluble. So this is a huge strength. So it's a carbon material. Graphene oxide now we can use in concrete. It improves the properties by large margins. That's where we've got some 3 PhD students working on this. I think we are probably right at the top of the world doing graphene oxide concrete. This building had graphene oxide. We had graphene oxide here. We had in the 4th floor columns graphene oxide. And Mr. Shomal encouraged a lot. Just go and do it. People can talk, but just doing it the difficult part. So we have done it here. So these sort of innovations, and one of the first in the world to use the graphene oxide in columns. Definitely the first in the world. I can give I can clearly see this building. So this building become famous for the graphene oxide, first building in the world as well. We can publicize that. We need to publicize this. So what is this doing? Is the compressive strength increased by about 40%. Graphene oxide. I'll leave it to another day. There are some papers under our name. Graphene oxide. It's a high performance concrete. That's the factory in Homagama. We have in Sri Lanka has a purest type of carbon, 99.5% purity, and so purest type of vein graphite that can be converted. Performance higher than normal graphites, so it can be used. But we need to convince the construction. It's not easy to convince the construction industry that that can be used. They always talk about only numbers, but what we said was, again, I don't have time to talk. If you use graphene oxide, because there's an increase in compressive strength, cement can be reduced, so 25% reduction. So sustainability has come as well in a big way to encourage the use of these type of materials. So we talked about this slab actually. This is a slab here. We talked about it already. Yeah, some things I forgot are the bottom ash being used as well in this slab and for the stairs as well. Solar panels, the big problem, again, we have a project trying to use solar panels. Solar panels is a big problem, eliminate solar panels. Now, so we are using that to convert into concrete. There's a name I gave, Solarcrete. Actually, industry person just grabbed the name, right? I don't think he'll give any money to me once he start making money. Solarcrete. You will see Solarcrete in the web, and I don't know whether I'm acknowledged for that. But so we talked about it already. We'll skip the facade ACP. We are using plastics. We are even converting into the shoes. this Kate Nguyen's project in RMIT. We working together on that. We can use, I know, over time, paper can be used. We are first trying out paper and cardboard waste in concrete. It's got good properties actually. Paper can be, this all been thrown now. So why can't we use paper as well in a systematic way? And the last one is on textile waste, right? We have lots of textile waste. And we can, once you use the textile fibers, yes, it absorbs water, it has problems, but even paper or textiles, but improves the tensile strength as well. So because they are fibers, so can be used to improve the tensile and the flexural properties. So these are solutions, right? If you start textile, even here, textile recycling facility and try to use that in big ways, you can make money, right? One day. So these are the opportunities. So I started talking about this talk. It's a very brief presentation on how net zero will give us opportunities, but all depends on solutions. We can't just wait for it to happen. We are the problem, right? But finding solutions will give us lots of opportunities in engineering to architecture to construction to all that. I will not talk today. I gave a talk in Sydney on for all engineers how the net zero will give opportunities, not only civil engineers, but electricals to biomedicals to everyone. But today my focus is on the construction side. So you see here, textile strength, see the tensile strength word. I said at the beginning, tensile is a problem for the concrete, tensile strength. We need to improve the tensile strength. So why not use some textile fibers to do that as well? But then it'll have some other problems when you use tensile, right? The biggest problem the concrete people will say is we don't have a bin for that, to store that. Why not? Just now 10, 15 years back when we were talking about recycled concrete aggregates, I had a PhD student from here, Mayuri. She was leading the whole SIM here at that time, the recycling part of it. So she came and did a PhD with me. When we did that, the main problem the concrete company said is we can't have another bin for recycled concrete aggregates. That's the reason they can't do anything at that time. But now everyone is going to have a bin. See the change in 10 years, right? So next 10 years when we talk about all concrete, we may have 100% of some of the recycled materials. So things are changing very quickly, right? So we have to grab the opportunities. There could be many other opportunities. You may have ideas of other opportunities. So we will include that. I think we'll conclude that. We're over time. So thank you.
Questions. So that now. So the first question is, could we know the feasibility of using plastic waste as aggregate in concrete?
I think it's a very good question. Today I didn't touch on that. So that's why again, that's why we had to go a bit deeper into that. Plastic waste, definitely plastic will give aggregates, but the problem is that we can look at the positives and negatives. Obviously, the plastic is a waste material. Why not convert into aggregates? We can use as plastic aggregates. However, the main problem will be the strength as well, because we want to make especially the higher strengths. We know I didn't go into that. Not the IT said so on. It breaks to the aggregates in higher strengths, because the paste is strong. If you make it paste strong, and we can, if you make the paste strong, still it can break through the aggregates. So plastic has some problems of the strength that way. So it has to be improved, but just higher tensile strength properties. So it have a bit of advantage. So we need to look at that. Also, some other concrete people have mentioned about the difficulty of mixing, and that's why I said yes, there are positives as well as negatives. Other thing we are used to is the shear strength of concrete comes from the aggregate interlock as well. Interlocking the aggregates. So we're going for normal aggregates with angular to a mixture of angular circular. Circular gives us the workability. Angular gives us a bit more strength. So what we do also is we are all used to what is called sieve analysis, and again have the grading, uniform grading, so that if you have large to smaller, that will pack the and give the packing density to the concrete. So the packing factor gives us a compressive strength actually as well. I'll leave it to another day. Water cement ratio we relate to, but the packing density is a key one. So that so because of that, plastic may have issues of really having that, giving the packing density. However, so low grade applications at the moment is fine. Getting to higher grade, there'll be issues. So this is why we need a lot more work. That's a very good question. Why not? The answer is, but there could be lots of low grade applications we can use. So we don't need to use for the the 100 MPa concrete, the plastic aggregates. But it's a very good question.
Construction industry incentivize the use of recycled materials in modular construction in developed countries such as Sri Lanka.
Right. I think it's again a very good question. So modular construction needs lightweight because we have to lift it up. So the cranes are a problem. So that's why one of the reasons that the modular construction didn't pick it up, the concrete modular. We are using lightweight steel and all that in Australia, but because of the weight. But Singapore is using PPVC systems, which are, and in Hong Kong as well. PPV systems are concrete, but Singapore allows a bit more, the cranes, the heavier cranes. Mr. Shomar may comment on this, but the cranes are an issue, and in buildings we have heavier cranes are a problem. How also in tall buildings we can't really, when it go taller, we have to really fix the, again, support the cranes and all that. So heavier cranes are a problem anyway. And the arm as well, or that the weight depends on the arm. So anyway, the answer to that question is that we should try and use lightweight materials. And we even talk about plastic aggregates. Plastic aggregates could be even bring those sort of things, could be bring some of the lightweight as well. And there are some lightweight materials. So modular construction is already a circular, right? We talked about the reduce waste, also things during construction. But of that, modules in the factories. Same time using, I think the question is more on the recycled materials being used. It's easy to use recycled materials in a shop, inside a factory, rather than going and use outside. So try and use that system, try to make it a good question. Try and use recycled materials as much as possible. And even timber can be used in some of the modular now, starting to be used. So low carbon materials are a choice, will become a choice, yes. I think if you have any questions, maybe you can, because we are running out of time, but the email to you, how about if you email to you, anyone else having questions? And then I'm happy to answer those questions.
Thank you so much, Ms. Priyan, for once again conducting this webinar for us. To conduct the very first webinar in this series. We're very glad to have you back here. Thank you all for joining us. We hope that the session was useful to you all and you'll be able to gain something from this. We will see you all then once again in the next webinar. Thank you and have a nice day.
Thank you very much. Also, can I just thank you for really organizing this, and I saw giving an opportunity for people to listen. And I know your WhatsApp is now gone over the limit. Your WhatsApp, the group. So it's very good that you got this YouTube thing. And also thank you to Mr. Sharma. He knows all this. Right now, still come and listen and giving this encouragement to the younger people to use these circular concepts, sustainability concepts, and as we have discussed. That's coming to the mainstream in a big way. Policy changes are happening. If the biggest change I see is the banks and superannuation funds really not funding any of the non-green type of projects, and that will happen to buildings. It's already happening. If they start, I mean, repeating here, but if they're starting to have 2%, 3% reductions from the ordinary interest rates because building is green. That means obviously they're going to do that. So these sort of changes, and the government changes as well, but more important, the private sector put in those incentives. So we'll become, anyway, so next time when I talk about this topic, yeah, I'm sure, like now there'll be newer policy changes would have happened, newer things in the world has happened. We all can contribute to that, right? So everyone can contribute to the solution. So again, think about the opportunities as well, right? Even as I said, start reading about carbon trading. I can assure you, right? If you put some money to some of these companies emerging now, uh, you won't. I'm sure you'll do well. Right? But don't take my word or record it. Bitcoin, it happened to Bitcoin. It won't happen to. My stories, I lost only $6,000 of Bitcoin. It'll, so it'll pick up anyway. So I think started to pick up again. So it'll be fine.
Process. So I think and this